Hi Salman. Hi Imran. How are you?
Um, how are you doing? How's it going? Varun, my sound is kind of like really heavy right now.
Sorry. Can you repeat?
I'm saying, how's it going? What's happening?
Nothing. Uh, Nothing much. I'm still trying to keep myself active actually.
Mhm.
So there are a few things that I get stuck at. So like one of the thing is when I was doing the future engineering part, I was trying to look at the variable names and like if I'm doing the simple imputer or the Canon imputer, then I'm not able to look at the feature like the feature names. I'm not able to get the name of them. So
Yes,
that was the one thing that I was struggling with.
yes. Means I think I will just put up the column names because when you split the data, the splitting part technically get rid of it, kind of like convert it into a NumPy array technically.
Right.
So what happens is all the column names are gone. Then you need to kind of like convert it into a data frame all over again. Since I was
Yeah.
doing it very kind of like I had very small amount of time in order to do it.
Yeah. I
So what I
understand.
did is basically for that time, I kind of like just skipped past that thing. But we can simply I did put the x dot columns thing somewhere, and
Yeah.
that basically contains all the column names, and we just need to attach it and make a different data frame. Excuse me. So if you are struggling with that, I will try to fix that up most probably whenever I'm starting to work on it. Most probably today, anytime means I would be starting to work on it. Most probably, I think in my afternoon.
Okay.
Yeah. So I will see
Thank
if I can add that up, and then I will just update it in all the data pipelines, and maybe that would be easy for everyone to go about. Yeah.
thank you.
Mhm. So,
Okay.
hi, Imran.
Hey, good morning, guys.
Good morning.
Good morning, Ron.
Good morning, Varun. How are you doing?
I'm good. How are you?
Doing well, just getting ready for work after this meeting. I have to go on site
Okay.
today. So I have
Here
a
it's night time.
you are in Australia, right?
Yeah.
What time is it over there?
It's 10.
Oh boy, okay, it's late. Yeah, there's always I don't it's always difficult to find the best time for everyone. It just
Yeah, it is because like people are from everywhere. So
yeah,
yeah,
Switzerland, India, you name it.
yeah.
Okay, let's get started, Salman. Since it will be recorded, so I think it will be fine. I think we already waited for 7 minutes, so that's enough.
Yeah. So I will kind of like go through the steps that I have explained in the Slack channel. So what exactly they mean, and I think we'll just start from there.
That's good.
Uh, Can you give me access to
Oh,
this?
sorry, my bad.
Okay, so over here, what I did is basically, so our goal is kind of like to improve the error metrics. That means if we are improving it, one strategy would not do the job, which means we would have to do hit and trial several different strategies. So few of the strategies that we can try for starting purposes. The first thing is simple, straightforward. We can just run the baseline model that I have created through all the pipelines and see which pipeline is giving us better results. That is the first thing we can do. Then whichever pipeline is giving us better results, we can go further deep down. So what we can do is means anybody who is starting their machine learning journey and they don't know much about many of the models, I would recommend them to stick to the baseline models if they are comfortable. If they want to break it down into one model at a time, like I broke it down yesterday, that if you want to do linear algebra or you want to play with it, you please play with it. Otherwise, if you're comfortable using the code that I have put on the baseline model, then run it through all the pipelines. That would and see what error metrics you are getting. I think Sunita kind of like did a really good job summarizing it in the table form. So she ran the results and she made it into a data frame. Maybe it is a data frame, or maybe she put it in the Excel or something. But this looks pretty organized, so all the models, they are giving best results, and she highlighted the best times and best error metrics and everything, and she highlighted that the LGBM and XGB, they gave us overall best results. Means this is what we have to do for every pipeline. We have to get this kind of output. We would be getting timings, we would be getting RMSEs or all the error metrics and everything. And we look at them and then we analyze which one is giving us better results. Then we picked that one. So the next strategy was something like that. The second strategy would be making a stack of the models. So like Sunita, she picked up that LGBM and XGB are performing better than the others. So pick top 3 best instead of 2, and we will try to stack them. So stacking is kind of like making an ensemble out of the model that we have already been using. So why this is helpful? Because stacking usually kind of like what it does is basically it gives you the ability to overcome the drawbacks of certain models by using other models. For example, KNN has different drawbacks and positives and negatives. Gradient boosting algorithms have different positives and negatives. Treatment means random forest has different positives and negatives. They are all different types because in the background, the working is different. Their drawbacks are different, which means they kind of like are good in certain things in which KNN is not good. Similarly, random gradient boosting is good in something where random forest is not good. So they kind of like cover up their bad things, and then we can stack it, and maybe we can improve the results by stacking them. So that would be the next strategy which we would be trying. So and we can, so if we once we try it on one baseline model or one pipeline, we can use the same exact code to run it through all the pipelines and pick the top 3 best, and means not top 3 technically. Try to use, we will try, since we have used about 12 different models, linear regression, lasso, or so many. It's not just that we can limit ourselves to just 3 models stacking up together. Maybe we can do 5 or maybe 6 or 7. Means if the we don't know what number of stacking models are going to give us better result. So we can try that. Once we have that for one pipeline, we can run it through all the pipelines all over again. So since we have these pipelines, so initially, my thought is, since we already have created 10, 11 pipelines, let's apply everything on those 10, 11 pipelines for now and don't change anything up above in the pre-processing part. But if we are getting some results and we are able to do that in a particular time frame, then the next strategy would be, we can kind of like, the third strategy would be feature selection. We can, right now, our strategy is, we are using, every single pipeline is using one single standalone feature selection technique. Like based on the light GBM, we are getting feature selection. What we can do is, we can do a voting, means we can go back and we can apply 3 different feature selection methods. For example, I can apply feature selection using random forest. I can apply feature selection using light GBM. I can apply feature selection using VIF or RFE or whatever, since we have applied several different. And based on that, every single feature selection method gives ranking to every feature, that this is important, it's important, this is the most important, this is second most important, this is third most important, and so on. What we can do is, we can make a data frame, we can assign them ranks, and then based on that, we can apply a voting method on it. Voting method, what it does is, basically, if one feature is being selected by 2 of the feature selection technique, then we will put it in the model. Otherwise, we will just drop that column. So this would be one of the way we can kind of like select the features. Instead of kind of like using just one feature selection method, we can use voting. Means if at least 2 of the feature selection methods are telling that this is an important feature, then we will keep it in the data. Otherwise, we will drop it. If only one is telling it, we will just drop it. So this is what voting means. So third strategy would be something. Yes, Imran?
So follow-up question to that is, then how many feature selection method are we gonna keep in at least targets, or at least based on those we're gonna test and pick the voting? We have to get a certain target, right?
So since we have already tried 4 of them, maximum is 4.
Okay.
Means I think VIF, we were not able to get much information out of it, interpreting or something. Maybe we can drop VIF, but the remaining rest of the 3 are fine. And they are all different techniques, because random forest has a different working. Yes, it uses trees, boosting, light GBM uses boosting and everything. It uses decision trees, but their mechanism is totally different, because one is kind of like a sequential, which kind of like learns from the mistake of the previous one, which is boosting, but random forests do not do that. So similar, that means they are different, which means
approaches are a bit different from backend anyway. So yes, in a way they are different.
Similarly, using RFE, I was using, maybe we can use linear regression or lasso or elastic net or whatever. That would be a totally different thing. So we can kind of like use 3 different things, and kind of like making a stack all over again, just like the model. So that would be the third strategy. And then after that, so this fourth one is, I think Imran and me, we both are implementing it anyways. So because this is a perfect data set to apply or practice your deep neural network things, because regression is the easiest task. And if you are kind of like want to get your hands on neural networks, this would be the easiest data to apply. So I would recommend kind of like just apply it. For that, if you have the book Hands-on Machine Learning by...
Let me share on our chat as well, so at least people, if they want to consult, they can.
Yes, means I think I will just maybe share the chapters 10, 11, 12, 13.
And then you can specify, right, those chapters. I'm going to post a book and then they can pick the chapters.
Yeah.
Yes, those are the one, 10, 11, 12, 13. Yes.
Maybe that, or maybe what we can do is...
Actually, 10 was mostly theory heavy. I think maybe later ones were fine.
I think chapter number 4 from Shali's book can also do the job, because there is a implementation of the regression.
That's a very nice chapter for sure.
Yeah, because there's a housing price problem implementation is there as well.
Yeah. Yes.
I have the PDF versions of it, so
You have it as well? Yes, you do have it as well. Yes, so yes, you can upload it as well if you wish. Otherwise, I'll
yes.
upload it. Okay,
So I
that's fine.
will upload that book for reference. Anybody who wants to kind of like just take their code and apply it onto our data set, because the only thing you are gonna need to change is the variables x underscore train or something from our data set into that data set. Other than that, it is kind of like you have plug and play. So I would recommend try that just for the sake of kind of like learning, and that would be good. And we will see what kind of a results we get. I'm not hoping to get a good results from deep learning or neural networks, but because they are kind of like overkill for now for this particular data set. But we will see what kind of a results we get. For a practice purpose, we will do that. And then after that, if we have time, and we got some results, I'm hoping that these particular strategies, we would be improving the results. So if we are improving the results, that's good. If we are not, then kind of like next strategy would be go back to the pre-processing and EDA. So we used a simple imputer, or imputation was simple or KNN. Now there is kind of like, I would be applying CAD boost encoding as well. What is CAD boost? CAD boost is just like, for example, it is a boosting technique, but this is one of the technique that kind of like can deal with the categorical variable as well, which means this particular technique, if you put the raw data in it, by dropping all the null values, it cannot deal with the null values. That is the only thing. Other than that, you don't even have to convert the categorical variables into numerical variables. Means you just throw in the data in the rawest form. It's gonna convert every categorical variable into numerical variable all on its own, applying several means whatever the best encoding technique would be, they would be applying. So technically in the background, the encoding that it does is it basically assigns pseudo encoding. Pseudo encoding means, for example, one facility type would not get, for example, let's say we have 60 facility types, and one facility type is getting a number assigned to it like number 4. So which means all the appearances or occurrences of that particular facility type will not be getting the number 4 based on all the data in that particular row. The number can be either 4.4, 4.8, 4.7, or something, which means it will give assigned pseudocodes or not just 4, which means based on the strength of the neighboring parameters and everything, it kind of like gives them pseudocodes. So it's a different thing, and it is right now being used on Kaggle in a lot of competitions, and it is getting good results. Top 1, 2, 3 results in majority of the time.
Nice.
So yeah, Imran, you were saying
No,
something?
nice. It's great that you brought this. I'm really excited to see how it works out.
And it is pretty straightforward. Just like all the boosting techniques, applying it is pretty straightforward because
The only thing is to just make sure on this there's no empty cells. You said that's all, no empty data. So you just have to make.
yes, you have to drop all the null values. That means the imputation part we have to do. Vandana said that we should try binary encode. No, that was encoding, I think. One said. I don't know where is it.
It's okay, we can.
Okay, I think Vandana suggested that we can apply binary encoding as well. So binary encoding, originally I was kind of like confused because of the name. The name was kind of like throwing me off. That I was thinking that binary would be 1 0 or something like that. And then later when I kind of like went up and looked it up, then I realized it is kind of like combination of two techniques: hashing plus binary encoding. Means first you're gonna applying an hashing algorithm and convert every category using hashing, and then convert it back into the binary numbers. So it's kind of like a very good technique, which means and it can reduce the dimension as well, because it's gonna limit it's gonna convert maybe the 60 categories into maximum 2 or 3 or 4 columns, because it will be just binary. It will be just giving the binary numbers to all the categories, because since we have 75,000, that means whatever number of columns are going to take up that binary number, that would be the biggest kind of like number of columns. So it also takes care of that. So we can also try that as well.
Interesting, for sure.
Yep. And another thing I was looking at was which I would be applying. For example, like these are few strategies. We kind of like did scaling. We used simple standard scaling. Standard scaling sometimes does not get rid of the bimodal or trimodal, because we have a lot of variables which have more than one nodes, more than one peaks or something like that. So that particular kind of distribution, usually standard scalar, we need to do either transformation like log transformation or something like that in order to kind of like do that. Skewness, for example, if something is left skewed or right, positive skewed or negative skewed or whatever, we need to do some log transformation, which we did not do. So we just applied simple standard scaling. What we can do is we can do quantile transformer. Quantile transformer is a technique in sklearn. What it does is basically its first argument is what exactly output kind of like a distribution you want. If you are selecting it as a normal distribution or a standard distribution, it's going to force it, it's going to apply all the techniques in such a way that the final distribution is going to be definitely normal. So what it does is basically it forces the distribution to be normal, and when it enforces the distribution to be normal, that means all the columns are definitely standard. Means standard scalar, yes, we are converting, standardizing it, but maybe it can be multimodal or something like that. There means it does not get converted into an accurate. Maybe we can try it and that can change the results or something like that. So we can always go back to the drawing board, and we can always do changes a lot of things in the pre-processing and EDA part. So maybe we can try dropping all the outliers. Previously, we were kind of like limiting the number of outliers when we were dropping them, but now we can maybe drop all of them or throw them in the model, and maybe that kind of like generalizes really well, way better than the the restrictions we are doing. So there are a lot of things we can do. We don't know what kind of a strategy is going to give us better results. So these are a few strategies I came up with, and if you want to add anything, since it is being recorded, people will be so I'm just saying it that if anybody wants to add any strategies in it and they want to try something, just keep on adding into it, so that we have kind of like a summary of that. We tried this, we tried this, we tried this, and try to keep a record of the results of every strategy we have tried, so that we can compare at the end which strategy gave us the better results. And then we can stick by that strategy. Since we have until 27th for this particular phase, I think until 27th, however many strategies we can apply, we will keep on applying.
Yes.
Yeah.
Thanks, Salman. Yes. Yeah. So feel free to add here. So it will really help us. So what in which direction we want to go to. Also, just a heads up, there will be some AWS element as well can come down the road. So just a heads up. I know some team Roy specifically, they will be working with Azure. So we will try, I have some experience on the AWS side, so I'll definitely try to bring that aspect in here as well.
That's great.
So just a heads up on that end.
Yep. So I think for AWS, what we can do is maybe once we have the best strategy that we are doing, we can for the final presentation or deployment part,
yep,
we can deploy that best model on AWS maybe.
That was the in my yeah. So yes, exactly. You're right. So because the idea is many recruiters are also asking for Azure. I was talking to Minister as well yesterday, or AWS. So it's good to get some sort of exposure for all of us.
Mhm.
Yes, that's a good idea. So since they are doing Azure, we'll focus on AWS.
Sounds good.
Sounds good. Okay. Anything else, Salman, you and I for today?
I think that's it for
That's
me.
the main gist of it, I guess.
What if you
One
add something?
question, yeah. With the CAT boosting, is it like a data feature engineering part, or is it like it is
CAD
it's a
CAD boosting does everything that, for example, light boosting does, but it
okay.
can also deal with the categorical variable. It can also do the encoding part as well, which light boosting cannot.
Do you have a nice
Oh,
any paper, Salman, on that? I'm really interested to learn about it.
I haven't searched for the papers yet, but Kaggle, if you go to Kaggle,
I'll check for sure.
recent competitions, all the top notebooks, all the top people, they have been applying it.
For sure, I'll check it out. Thanks for sharing. Definitely,
thank you. Yeah.
good stuff.
This is something. It is not many people knows about it. I was reading an article where they were comparing the popularity of XGB as compared to Cat Boost. Recently, Cat Boost is been outperforming XGB in majority of the competitions. And the popularity is not getting up, means because I think since it is from the company Yandex from Russian Google. So I think maybe they are not marketing really well, but only the people on Kaggle I have seen them using it, but I could not find. Yes, there are good articles out there, analytics vidya or towards data science or something. You would find some articles on Medium or something, but I did not search for research papers, but there are very good notebooks on Kaggle, which are very well detailed, explaining what exactly they are doing, or how it is used as an encoding technique, or how it is used as a model through the complete model. So what people do is a lot of kind of like gold gold notebooks. What they do is they basically just start the competition and throw everything, drop all the columns and throw it in the CAD boost, and that would be the first notebook that they throw in. So, that is first kind of like baseline result that they got without doing any EDA whatsoever.
Nice.
So that is what they have been doing. Yeah.
Well, thanks for bringing that up. Really excited. I'll check it out. Some stuff on Kaggle today.
Yeah.
Anything else we want to add?
No, I'm good.
Also, how about in terms as far as meetings are concerned? Any idea? Well, I guess we'll put on chat. Let's see what people say, and then we'll decide, I guess, a bit early.
Yeah.
Okay, nothing from. Okay, go ahead.
Imran, means our regular meetings, what's going to happen in the regular meeting? So since our regular meeting would be combined general meeting, what would be happening in those meetings?
So like we discussed in Teams meeting or Leaders meeting last Saturday, so we are hoping that teams will be presenting. Now this Wednesday, Rich's team is a team number 1, right? Okay. He said he will cover whatever most they could have done by this Wednesday, but apart from that, after that, they will give a final of whatever they have done, what they are supposed to deliver by. We might organize a special meeting for them this week on Friday, and then it will be us on Sunday.
Okay, sounds good.
And then in the same order, 1, 2, 3, 4.
Sounds good.
And Sunday, actually, based on that meeting, we decide maybe there will be 2 meetings. 2 teams will present, team 2 and 2, 3.
Okay.
So maybe I need to give a proper announcement so at least everybody's on the same page.
Yeah. Do we have the recording for that meeting?
This one for which meeting? The lead one?
That team lead one.
No, that one I didn't record deliberately, because that was on a Google Meet. My bad. I never thought of that. Okay. My bad. That wasn't, but we can still discuss it. I'll call you on that. Yes. But this one is recorded. I'm just not particularly sure where I need to make an announcement today for all leads. Where should we record these meetings? I'm going to ask Rich because he's also busy. He works as well, so I don't know.
Means I think we should not be putting it. That would be too much on Rich.
Right? No, I don't want to ask him anyways.
Yeah.
Actually, you know what? Maybe I was thinking just right now. Maybe I'll just put it in our own project management folder. I'll just create a separate tab for leads videos, and then they will do it. Okay, sounds good. I'll do.
Sounds good.
Okay, thanks guys. Thanks for coming.
Yep.
Have a good day. I need to get ready for work now. Bye bye.
Thank you. Have a good day. Bye.
You too. Bye bye.